Grumpy Cat and I welcome you to your R1 presentation. Get ready to take some notes on polynomials. Okay, so your finite math book starts with an algebra review, which is really good. So, the first section of this algebra review will help you go back over the definition of a polynomial and also adding, subtracting, and multiplying polynomials. So let's get started, and the first thing we're going to start with are some basic definitions. The expression 5x to the fourth is a term. 5 is the coefficient of the term, x is the variable, and 4 is the exponent. We're going to fill in the blank for these. 7p to the fifth is a term. 7 is the coefficient, p is the variable, and 5 is the exponent. The expression 3x to the seventh minus 4x to the fifth formed by two unlike terms, 3x to the seventh and 4x to the fifth. And they are unlike terms for basically one reason. They do have the same variable x, but they're to different powers. Okay, x to the seventh and x to the fifth are different powers of x, and so they can't be combined to form a single term. The expression 5y cubed plus 6y cubed is formed by two like terms, 5y cubed and 6y cubed. The two terms 5y cubed and 6y cubed are like terms because they have the same variable y and the same exponent 3. So we could combine them together by just adding the coefficients. 5 plus 6 is 11, so it would be 11y cubed. So what is a polynomial? A polynomial is a term. So each of those single terms that we looked at, those are little baby polynomials. Or a finite sum of terms. Okay, you've got a little string of terms added together, in which all variables have whole number exponents. That's the other thing. So remember, whole numbers start with 0 and then include all the integers larger than 0. So 0, 1, 2, 3, 4, and so on. And no variables appear in denominators. So if you'll remember from Algebra 2, a negative exponent is just a way of saying, oops, this use the reciprocal of the base. So use the reciprocal of the variable. So it's kind of hiding the fact that the variable is really in the denominator. Okay, so here's an example of a polynomial with three terms, 4xy squared plus 3x minus 5. Okay, we've got three little terms there. All right, we're going to decide whether the function given below is a polynomial function. If so, we're going to state its degree. The degree is just the largest exponent and its number of terms. So we've got h of x equals 9x to the fourth minus 1/4 x squared plus 16. So let's look. It is a finite sum of terms. Okay, we've got three terms there added together. We've got an x to the fourth term, an x squared term, and then just a constant, so that's fine. Sometimes people worry about that 1/4 as a coefficient. That's fine. You wouldn't want a 1/4 as an exponent. You don't want a fraction or a negative as an exponent, but it's fine for coefficients. So this is a polynomial. It has a degree of 4 because that's the largest power, and it has three terms. Okay, let's look at the next one. h of x equals 9x to the negative fourth power minus 1/4 x squared. Well, at first you may think, oh, okay, that one's fine. Doesn't look that much different from the first one. The problem is that negative 4 is not a whole number. It's a negative, and so really that means 1 over x to the fourth power. Remember, a negative exponent means take the reciprocal of. So this would not be a polynomial. Because of the negative exponent, this is not a polynomial function. All right, so we're going to simplify the following. Only like terms may be combined, and by combined we mean added or subtracted. Okay, you can pretty much multiply anything together, but adding and subtracting you have to have like terms. So let's start with the ones that we looked at before, 5y cubed plus 6y cubed. Those are like terms because they have the same variable and the same power, and so we can actually combine these, and the way that you do that is you just look and go, okay, this is an addition problem, so we're just going to add our coefficients together, and that gives us 11y cubed. Okay. Same thing here, we've got negative 3a squared plus 4a squared. They have the same variable and the same power, so we can combine them. negative 3a squared plus 4a squared. Negative 3 plus 4 is 1, and so that's 1a squared or just a squared. Now, I do want to pause right here and tell you, I have 2 little dogs, and if you ever hear somebody barking in the background, it is either Daisy or Scout, and I apologize for that. I'll try to keep it to a minimum, but it's just going to happen sometimes. All right, so 3x to the 6th minus 2x to the 5th. Well, both terms have x's, but they have different powers. So there's nothing we can do about that. That's as simplified as it gets. It's just 3x to the 6th minus 2x to the 5th. On part D, at first you may go, oh, okay, that's all we can do because, you know, we've got one term with an A, one term with a B, one term with a -1. That's true, but remember, by combined, we mean added or subtracted. That's when you have to have like terms. To distribute that negative, it doesn't matter. We can go ahead and distribute that, and we will have a simplified expression. So anytime you have a negative outside parentheses, what's going to happen is it's going to get rid of it, it's going to change the sign of everything inside the parentheses when you distribute it. So we're going to end up with positive a minus 2b plus 1. Okay, so now let's look at some, not just combining terms, but actually adding 2 polynomials and subtracting 2 polynomials. Okay, for addition, we've got 2x squared minus 11x plus 8. And then we're going to add to that the polynomial 7x squared minus 6x plus 2. You can just drop the parentheses and then combine like terms. So that just equals 2x squared minus 11x plus 8 plus 7x squared minus 6x plus 2. So let's combine like terms. 2x squared plus 7x squared is going to give us 9x squared. Negative 11x minus 6x gives us negative 17x. 8 plus 2 gives us 10. And so now we're down to a trinomial that's as simplified as we can get. So we are done. Now, for part B, we're going to be subtracting a polynomial from the other. So we've got negative 4x to the 4th plus 6x cubed minus 9x squared minus 12. And we're going to subtract from that negative 3x cubed plus 8x squared minus 11x plus 7. Now, for the first set of parentheses, we're just going to be able to drop it. Now, remember what we did in the last example when we had a negative in front of parentheses? In order to simplify that away, remember you change the sign of everything inside the parentheses. So that's what's going to happen. That is how we actually incorporate subtraction into the problem. So you'll notice we just copy what's in the first set of parentheses, negative 4x to the 4th plus 6x cubed minus 9x squared minus 12. But then we apply that negative to everything inside the second set of parentheses, and we change all the signs. So plus 3x cubed minus 8x squared plus 11x minus 7. Now we just combine like terms. Now negative 4x to the 4th is the only x to the 4th term, so we just write that down. 6x cubed plus 3x cubed is 9x cubed. Negative 9x squared minus 8x squared is negative 17x squared. Let's see, there's not an x term there, so let's keep going until we find one. So we've got 11x. It doesn't have a buddy to combine with, so it's just plus 11x. And then we'll go back and we'll pick up that negative 12 minus 7 gives us negative 19. Notice we do want to make sure our final answer, we go in decreasing degree of x. We want the x to the 4th term, then the x cubed, then the x squared, then the x, and then the constant. Okay. They're all different types of terms, so we can't combine anymore, so we are done. Okay, for example 5, we're going to multiply. Tells us to simplify. We know to multiply because we've got multiplication is indicated. And so we've got 7x times 2x minus 1. We want to distribute the 7x, so we're going to multiply 7x times 2x. Then we're going to write down minus and multiply 7x times 1. So we're going to have 14x squared minus 7x. Those are not like terms. We are done. Now, on the next one, we've got 2p minus 5 times 3p squared plus 3p minus 1. So we're going to do the repeated distributive property. We're going to take 2p and we're going to distribute it to everything in the second polynomial. Then we're going to take negative 5 and distribute that to everything in the second polynomial. All right, 2p times 3p squared gives us 6p cubed. And then 2p times 3p gives us 6p squared, so plus 6p squared. And then 2p times negative 1 gives us minus 2p. So there's that. Now we're going to come back with the negative 5. Negative 5 times 3p squared gives us negative 15p squared. Negative 5 times 3p gives us negative 15p. Negative 5 times negative 1 gives us plus 5. So let's combine terms. 6p cubed doesn't have a p cubed buddy to combine with. 6p squared minus 15p squared gives us negative 9p squared. Negative 2p minus 15p gives us negative 17p, and then plus 5. All the terms are different, so we can't combine anymore. Okay, for part C, we've got x minus 2 times x plus 1 times x minus 3. So we've got 3 factors. What we're going to do is we're going to multiply 2 of them together, and then take that product and multiply it by the third. Now, we're going to have to do repeated distributive property again, but remember on the first pair that we multiply, because we have a binomial times a binomial, if it's helpful, you can remember that this special case of binomial times binomial multiplication can be remembered as FOIL. The first terms, the outside terms, the inside terms, the last terms. So if that helps you, that's great. So let's look at that in action. So x times x, those are our first terms, is x squared. X times 1, our outside terms, gives us plus x. Negative 2 times x for our inside terms gives us negative 2x. And then negative 2 times 1 for our last gives us negative 2. But it's just a way of remembering how to do the repeated distributive properties. So don't feel like you have to do. If remembering FOIL helps you, that's great. If it doesn't, don't worry about it. Just remember repeated distributive property. Okay, so let's combine terms. The only 2 terms we can combine are x and minus 2x to give us minus x. So now we've got a trinomial times a binomial, so we'll do the repeated distributive property again. So x squared times x is x cubed. X squared times negative 3 is negative 3x squared. Negative x times x is negative x squared. Negative x times negative 3 is plus 3x. Negative 2 times x is negative 2x. Negative 2 times negative 3 is positive 6. All right, combine like terms. We've got x cubed, negative 4x squared, 3x minus 2x gives us x, and then plus 6. And so we can't combine any further, and so that's our final answer. Okay, guys, that's it for this lesson. Make sure you do the problems to try on your own before next class. Remember, if they're not done and done well, then you don't get full credit for your notes. So make sure you do them. It's an important part of learning. That's the big thing, is that it reinforces what you've just learned if you can do them. If you didn't understand this lesson well enough to be able to do the problems to try on your own, you have a couple of options. You can go back and rewatch the video and then try to do them, or you can come in and get help from me and then try to do them, or you can go in for a peer tutoring and then try to do them. Okay, those are your options, but they need to be done before you get to class. Okay, guys, have a great day. We'll see you soon.